Hello. We will now discuss methods of solving linear inequalities. You remember in the first unit we talked about the inequality signs and how we can use to determine if a statement is true or false. Well, once you have that understanding, we are going to use those symbols and solve inequalities. Now, to start with, tell me, what is the difference between an equation and an inequality? Well, look at this. X plus 2 equal to 5 is a linear equation. Is that right? It has just one solution. It means there will be only one value of x that will make this statement true. What will be that value? That will be x equal to 5 minus 2 equal to 3. Only 3 will make that statement true. That means an equation has only one solution. But look at this statement, x plus 2 is greater than 5. Now, this is an inequality statement. It is not an equation. It is an inequality statement. X plus 2 is greater than 5. Now, there are infinite solutions for these inequalities. You see the difference between an equation and an inequality? The equation x plus 2 equal to 5 has just one solution, whereas the inequality x plus 2 is greater than 5 has infinite solutions. How? Now, to solve an inequality, first we isolate the variables to the left side, just like we do to an equation. Almost every step that we normally follow to solve an equation, we can use to solve an inequality. So to solve this inequality, x plus 2 is greater than 5, we keep the variable on the left side and move the number to the right side. So let's move positive 2 to the right side. Now, when you talk about the left side or the right side, I'm talking about the left and right of the inequality sign. Greater than is the inequality sign. Moving plus 2 from the left to the right will become minus 2. We get x greater than 5 minus 2. That means x greater than 3. You see, this statement will become true if x has any value greater than 3. For example, x can have a value 3.1, x can have a value 3.01, x can have a value 2000, x can have a value 100.6. There are infinite values of x that will make this inequality statement x greater than 3 true. So any number greater than 3 is a solution of this inequality. Alright, now x is greater than 3. Let's have a look at that. X is greater than 3. Now this solution can be represented graphically on the number line. How do you represent a solution graphically on the number line? X can have any value greater than 3. Now, can you have x equal to 3 as a solution? Now, can you say that 3 is greater than 3? No, you cannot have x equal to 3. You cannot have x any number less than 3. But you can have any number greater than 3 as a solution of this equation. And look at the way I'm going to represent that on the number line. I will put a parenthesis at x equal to 3 facing right, because look at the way the inequality is facing. It is facing right. So put a parenthesis and x equal to 3 facing right and put an arrow, which means any number from 3 but 3 not included. And that is the reason why we put a parenthesis. When you put a parenthesis on a number, it means that number is not part of the solution. You understand that? When a parenthesis is placed on a number, it tells you that that number is not part of the solution. So the solution of this inequality, x greater than 3, is all numbers to the right of 3 as indicated by the arrow. But 3 itself is not a solution. That is what the parenthesis tells you. The parenthesis indicates that 3 is not part of the solution. But any number greater than 3, for example, 3.00000006 is a solution. But 3 is not a solution. Any number greater than 3 is a solution. Now, this solution can be expressed as an interval. What is the meaning of an interval? An interval always has a beginning and an end, from something to something else. That means this solution of this inequality is actually an interval of numbers. It has a beginning and it goes all the way to positive infinity. So how do we write that as an interval notation? Watch how it is written. Parenthesis 3, comma, infinity, parenthesis closed. Now again, when you write a number after parenthesis, it tells me that this number 3 is not part of the solution, but anything greater than 3 all the way to infinity is a solution. Now, what does it mean I used a parenthesis for infinity? When you have a parenthesis, it means that number is not included. Well, do you know where infinity is? Nobody knows where infinity is. If you can give me an infinite number, I can give you a number more than that. So nobody knows where infinity is. That means there is no point in saying that infinity is included. It makes no sense. Okay, I want you to learn this concept. On the number line, the solution x greater than 3 is represented by putting a parenthesis facing right and an arrow all the way to infinity. And it means the solution of the inequality contains all numbers to the right of 3. 3 is not included. The parenthesis tells you that 3 is not included. And in the interval notation, it is parenthesis 3, comma, infinity. Now this also means the solution contains all numbers to the right of 3. 3 is not part of the solution. Okay, let's move on. Let's now solve x plus 2 is greater than or equal to 5. Greater than or equal to 5. That's a different inequality sign. Alright, what do you do to solve it? To solve this, we take the plus 2 from the left side to the right side. What does that become? We have x greater than or equal to 5 minus 2. Or it gives me x greater than or equal to 3. Well, there is a small difference there from the previous solution. What is the difference? This time, x equal to 3 is also a solution. In the previous case, x greater than 3 did not include x equal to 3. Whereas here, x is greater than or equal to 3 means any number starting from 3 all the way to infinity is a part of the solution. So x equal to 3 is part of the solution. X can have any value from 3 to infinity, including 3. And how do we represent that on the number line? Alright, watch here. The difference is, on 3, previously we used a parenthesis. What does the parenthesis represent? The number on which the parenthesis is standing is not included. But this time, our 3 is part of the solution, so I put a square bracket facing right on 3. The square bracket means that number is included. And now we put an arrow to the right. Okay? So what does this mean? This means x equal to 3 or greater than 3. The bracket indicates that 3 is part of the solution. I hope you understand the difference between using a bracket on a number and a parenthesis. A parenthesis on the number tells you that that number is not part of the solution. But anything to the right is part of the solution. Bracket tells you that the number also is a part of the solution. So x equal to 3 is a solution. Anything to the right of 3 is also a solution. And how do you represent this solution using interval? Well, in place of the parenthesis, we now use a square bracket. Square bracket 3, infinity is the numbers starting from 3 all the way to infinity, including 3. Now, as I told you, there is no point including infinity. Infinity, every time you have an infinity, you use a parenthesis for that. Alright, let's now look at another one. Solve the inequality x plus 2 is less than 5. This time, the inequality sign is facing left, less than 5. Now to solve it, we move the positive 2 from the left to the right. So what does that become? X is less than 5 minus 2, or x is less than 3. Can you represent this on a number line? X can have any value from negative infinity. Now look at the way I'm going to say it. The inequality sign is facing left. Now any interval that we discussed, the interval always must start from the left and go towards the right. An interval can never start from the right and go to the left. No. You see, we live in a world where we write from left to right. Is that right? Everything starts on the left and goes towards the right. Numbers start from left, where? Negative infinity, and goes all the way to positive infinity. So an interval, if you want to mention an interval, the starting point of the interval will be on the left, and the ending point will be on the right. And so, how will we represent this? X is less than 3 means all the way from infinity to 3, but 3 is not a solution. Is that right? Okay. Now, this solution can be represented on the number line. How? Put a parenthesis on 3 facing left. Look at that, less than 3. Put a parenthesis on 3 facing left. What does the parenthesis on 3 tell you? That the 3 is not part of the solution. And then an arrow to the left. Now, what is therefore the solution? The solution contains all numbers from negative infinity all the way to 3, but 3 itself is not included. So the parenthesis which is facing left indicates that 3 is not part of the solution. Tell me, how will you write that as an interval? On the interval, you remember always an interval starts from the left and come to the right. This is the left end of the interval and this is the right end. The interval starts all the way from negative infinity to 3. 3 is not included. The parenthesis tells you 3 is not included. Alright, remember this, an interval is always specified from left to right. Okay, we know this. A parenthesis to the right of 3 indicates that 3 is not included in the solution values. How will you represent then a solution like this? Can you do that on your own? X less than or equal to 3. What will be the representation on the number line? Less than or equal to 3. The only difference this time is that X also includes 3. So what will you do on 3? Put a square bracket on 3. It means X equal to 3 is now a part of the solution. X equal to 3 is now included. And now an arrow to the left. Okay, can you write this as an interval? How will that be written as an interval? All the way from negative infinity to 3, and it will be like this. Parenthesis negative infinity, comma 3 square bracket. The square bracket tells you that 3 is part of the solution. Alright? Remember, an interval always starts on the left and end at the right. Okay, let's now look at another statement, an inequality statement. What does this mean? Negative 2 less than x less than 5. Now, what this means is that the values of x are between negative 2 and 5. In other words, the interval in which you can find the values of x has a left boundary of negative 2 and a right boundary of 5. That's the meaning there. Now, is negative 2 included in the solution? No. Is 5 included in the solution? No. So what does this mean? That x can have values from negative 2 to 5 excluding negative 2 and 5. Negative 2 and 5 are not included, but any values in between, x can have any value in between those two. And how will you represent that on a number line? Well, you know that when negative 2 is not included, it will be a parenthesis on 5. Now, you notice that sometimes when I want to put a parenthesis right on 5, the computer doesn't let me. So here, I want to put this parenthesis right on 5, and it is facing left. And we'll put another parenthesis on negative 2 facing right. What does that mean? This parenthesis is facing left, means we will find the solution numbers to the left of it. And this parenthesis is facing right, means the solution numbers can be found to the right of it. So, it means the solution for this inequality can be found from negative 2 to 5, any number in between, and I put a line in there. But negative 2 is not included, positive 5 is not included. How will I write that on the interval notation? Alright, watch this. Parenthesis, negative 2, comma, 5, parenthesis. This means the left boundary of the solution interval is negative 2. Negative 2 not included. And the right boundary of the solution interval is 5. 5 is not included. but any number between -2 and 5 is part of the solution. Okay, I hope you understand the concept. A statement of the form -2 less than or equal to x less than or equal to 5 means, what's the difference here? This time the end numbers are also included. So in place of the parenthesis, we will now use a square bracket. So on the number line, I will have a square bracket on -2 facing right, a square bracket on 5 facing left, and I'll put a line in between. So all numbers from -2 to 5, including the end numbers, are part of the solution. And on the interval notation, how do we write that? That will be bracket -2, 5, bracket closed. It means all numbers from -2 to 5, including -2 and 5, are solutions of this inequality. Okay? How about this? A statement of the form -2 less than or equal to x less than 5. Can you represent that on a number line? What does it mean? It means the values of x, the solutions, can be found in what interval? From -2 to 5, including -2, but excluding 5. So we will have a square bracket on -2 and a parenthesis on 5. Look at this. Square bracket, -2, 5, parenthesis. It means -2 is included, 5 is excluded. Anything from -2 to 5, including -2 and excluding 5. And on the number line, I will have a square bracket on -2. This square bracket must be on -2. And a parenthesis on 5. And a line in between. So the solution for this inequality statement contains all these numbers, including -2, but excluding 5. How about this? You must be now able to do this on your own. -2 less than x less than or equal to 5. This time -2 is not included, but 5 is included. So on the interval notation, -2, 5, bracket. -2 not included, 5 is included. And on the number line, we have a parenthesis on -2, a square bracket on 5, and a line in between. Okay. Both sides of an inequality can be divided by a number. In solving the equation, we found we can divide the left side of the equation and the right side of the equation by the same number without changing the equation. We can do the same for an inequality. Both sides of an inequality can be divided by a number without changing the value of the variable. But care must be taken when dividing an inequality by a negative number. You see, there is no problem in dividing an equation by a negative number. But when you divide an inequality by a negative number, there is a little problem. Let's see what that problem is. Let's look at the inequality 5 is greater than 3. Is that a true statement? Yes, it is. 5 is greater than 3 is a true inequality statement. All right. Let's divide both sides of this inequality by -1 and see what happens. 5 divided by negative 1 is greater than 3 divided by negative 1. We divided both sides by negative 1. Now, what does it tell you? It tells me negative 5 is greater than negative 3. Now, is that a correct statement? No, because negative 5 is not to the right of negative 3. Negative 5 is on the left and negative 3 is on the right. So negative 5 is actually less than negative 3. So we have a correct inequality statement we started with. When you divided that inequality by negative 1, both sides by negative 1, we got a statement that is not true. Now, tell me, how can you make this statement true? This statement can be made true by simply inverting the inequality sign. Is that right? Now, this is not a true statement because negative 5 is not greater than negative 3. But this statement can be made true by reversing the inequality sign. What does that mean? Greater than is to be made less than. Simply reverse the inequality. So, it means negative 5 less than negative 3 is a true statement. And therefore, what is the precaution that you need to take when you divide an inequality by a negative number? There is a precaution you need to take. And that precaution is, when you divide an inequality by a negative number, when you divide an inequality by a negative number, you must reverse the inequality sign to make it true. Alright, don't forget that. I'm going to keep telling you this all the time. Very important. When an inequality is divided by a negative number, the sign of the inequality will reverse. Always remember that. When you divide an inequality by a negative number, the sign of the inequality has to reverse. Alright, let's practice some examples. Express the inequality on a number line and also using the interval notation. X greater than 5 over 2. Can you represent the solution? This is a solution of an equation. Represent this on a number line. Tell me, where do you locate the number 5 over 2? 5 over 2 is 2.5. It's somewhere here. Tell me, are we going to use a parenthesis or a bracket? X greater than 5 over 2. 5 over 2 is not included, so we use a parenthesis. Alright, tell me, is the parenthesis going to face right or is it going to face left? Greater than is going to face right. So this is 2/5, parenthesis facing right, and an arrow to the right. That is the solution. X greater than 5 over 2. 5 over 2 is not included, but anything to the right is included. And how do you write that on the interval notation? Watch this. Parenthesis, 5 over 2, comma, infinity. Don't read it as a square bracket. Now this is the way parenthesis comes in on the computer when you have a large number to enclose. So parenthesis, 5 over 2, comma, infinity. In other words, all numbers from 5 over 2 to positive infinity, excluding 5 over 2, is in the solution set. Alright, how about this? Negative 2 less than x less than 3. Can you represent this on a number line? Well, that must be simple. Negative 2 less than x less than 3 means the values of x can be found between -2 and 3, but are these end numbers included? No, excluding -2 and 3. So on -2 we use a parenthesis facing right, and on 3 we use a parenthesis facing left, and then put a line in between. Alright? Anything between -2 on the left and 3 on the right are solutions, but -2 and 3 are not part of the solution. And on the interval notation, it will be parenthesis, -2, comma, 3, parenthesis. Okay. Another one. Express this on the number line and also using the interval notation. X less than or equal to -6/5. Now, where will you find the -6/5? -6/5 is slightly to the left of -1, and it is included. So, you will use a square bracket there. Where will it be? It will be somewhere here. -6/5 is there. A square bracket at -6/5, and less than or equal to facing left, an arrow to the left. So all the numbers, watch again here, I'm going to talk in terms of the interval. All numbers from -infinity to -6/5 is part of the solution, including -6/5. How will you write the interval notation? On the interval notation, tell me, how do I start it? It will be parenthesis, -infinity, comma, -6/5, square bracket. There you are. Parenthesis, -infinity, comma, -6/5, square bracket. Another one. -2 and 7/8 less than or equal to k less than -1 and 2/3. Well, can you locate these numbers on the number line? -2 and 7/8 will be somewhere here. Will we use a parenthesis or a square bracket there? Less than or equal to. This is included. So -2 and 7/8 is included. There you are. -2 and 7/8 square bracket facing right. And -1 and 2/3 will be over here. That is -1 and 2/3, and any number in between. Okay, let's move on. How will you write that on the interval? It will be bracket -2 and 7/8, comma, -1 and 2/3, parenthesis, because -1 and 2/3 is not included. Alright, let's do a simple problem now. Solve the inequality and graph the solution on a number line, and also give the solution using the interval notation. I hope you understand the interval notation by now. An interval will have the left boundary, comma, the right boundary, and you will either use a parenthesis or a square bracket depending on if the boundary numbers are included or excluded. Alright, this is the inequality we have. 9b minus 5 less than or equal to 5b plus 7. Well, just like we do for an equation, we first move the variables to the left and the numbers to the right. So what will you do here? Move -5 from the left to the right. What will it become? it will become positive 5. And 5b from right to the left, it will become minus 5b. So 9b minus 5b less than or equal to 7 plus 5. And what is that now? 9b minus 5b is 4b. 4b is less than or equal to 12. And now divide both sides by 4. That will be 4b divided by 4 less than or equal to 12 divided by 4. Remember, we are now dividing by a positive number. Dividing by a positive number will cause no problem. The problem comes only when you divide by a negative number. Alright? We are now dividing the inequality by a positive number, so there is no problem. 4 and 4 will cancel. We get b less than or equal to 3. Is that right? That's a very simple statement. Now, how would you represent that on a number line? B less than or equal to 3. Now, the sign is facing left. B can have any value starting from where? Starting from negative infinity all the way to 3, including 3. So, I'll put a square bracket on 3 facing left, and then put an arrow all the way to the left. And how will you write that? Using interval notation. B can have values starting all the way from negative infinity, look at the way I write it, negative infinity to positive 3 included. Okay, let's go to another one. Solve the following inequality and graph the solution on a number line, and also using the interval notation. Okay, that is 1.4x plus 2.2 less than 2.6x minus 0.2. But there is no difference here. The same thing. We move the number 2.2, positive 2.2, from the left to the right. It will become negative 2.2. And 2.6x, we move it from the right to the left, it will become negative 2.6x. Look at this. 1.4x minus 2.6x less than negative 0.2 minus 2.2. Alright? Alright, combined terms now. What is 1.4x minus 2.6x? Well, just look at the coefficients. What is 1.4 minus 2.6? Will the answer be positive or negative? You have a positive number and a negative number. The answer is negative. Negative 1.2x less than negative 2.4. You see, negative 0.2 minus 2.2 is negative 2.4. Okay? Alright. Now, we need to get x alone on the left side. What do? Divide by negative 1.2. And what did we say that we need to take care when you divide an inequality by a negative number? When you divide an inequality by a negative number, you must reverse the sign of the inequality to keep it a true statement. So, divide both sides by negative 1.2. When you divide by a negative number, you must reverse the inequality. Now look at this. Remember to reverse the sign of the inequality when you divide by a negative number. When you divide by a positive number, there is no problem. But when you divide by a negative number, you must reverse the sign of the inequality. So look at the way I'm doing it now. this is the inequality we have. Negative 1.2x less than negative 2.4. Divide that by negative 1.2. Negative 1.2x divided by negative 1.2. Now, the less than now becomes greater than. Reverse the sign of the inequality. Greater than negative 2.4 divided by negative 1.2. I hope you understood it. Alright, on the left the negative 1.2 and cancels with negative 1.2. What is negative 2.4 divided by negative 1.2? Well, negative divided by negative is positive. And 2.4 divided by 1.2 is actually 2. Because 1.2 multiplied by 2 is 2.4. So we get x greater than 2 is the solution. Alright, on the number line, what will you do? On 2, use a parenthesis. That parenthesis must sit on 2. Means 2 is not included, but anything to the right of 2 is included. X is greater than 2. And on the interval notation, how will you write as an interval? Parenthesis 2, comma, positive infinity, parenthesis. And that is the interval notation. Okay. Another one. Solve the inequality and represent the solution on the number line. And also as an interval, you must learn both. 4 minus 3x less than or equal to 7 plus 2x plus 4. Okay, what is the first step you will do here? What I will do is combine the terms on the right. 7 plus 4 is 11. So the inequality now becomes 4 minus 3x less than or equal to 2x plus 11. Okay, in the next step, move the 4. See, 4 is positive on the left. Move it to the right, it will become negative. And move the 2x from the right to the left, it will become negative 2x. So, we have moving, we got negative 3x which is already on the left. We moved 2x from the right to the left, became minus 2x. Less than or equal to 11 is already on the right. And move the positive 4 from the left to the right, we get negative 4. Negative 3x minus 2x is less than or equal to 11 minus 4. Tell me, what is negative 3x minus 2x? They are both negative. So simply add them together and use the negative. That will be negative 5x less than or equal to 11 minus 4 is 7. Negative 5x is less than or equal to 7. Divide both sides by negative 5. And when you divide an inequality by a negative number, reverse the inequality sign. Divide by negative 5 and reverse the inequality sign. Alright, watch how I do that. Negative 5x divided by negative 5. Now less than or equal to becomes greater than or equal to. When you divide by a negative, reverse the sign. Is greater than or equal to 7 divided by negative 5. And on the left, negative 5 and negative 5 will cancel. You have simply an x. So x is greater than or equal to 7 divided by negative 5 is negative 7 over 5. Can you represent this on a number line now? X greater than or equal to negative 7 over 5. Where is negative 7 over 5? Isn't it somewhere here? Negative 7 over 5 is actually to the left of negative 1. Is that right? This must sit a little to the left of negative 1. Negative 7 over 5 must be a little to the left of negative 1. Alright? And all the way to the right. How will you write that on the interval? X greater than or equal to negative 7 over 5 means the left boundary is negative 7 over 5, that is included, comma, all the way to infinity. This is the interval notation of that. Okay, you need to practice these kind of problems. Very, very, very important. Another one, solve the following inequality and graph the solution on a number line. H over 2 minus 5 over 6 less than 7 over 8 plus h. Now we are faced with a situation, we have now fractions. Now what did we say we do when we have fractions in an equation? We will get rid of the denominator. In the same way, we use the same in solving the inequality. We get rid of the denominators. Now, what is the denominator for h? It is 1. H is h divided by 1. So multiply every term by the LCD of 2, 6 and 8. I don't think you need my help now to find the LCD of 2, 6 and 8. It is 24. So multiply each term by 24. And it will look like this. 24 times h over 2 minus 24 times 5 over 6 is less than 24 times 7 over 8 plus 24 times h. Multiply every term, each term by 24. And now we simplify each term. Look at the first term. 24 on the numerator, 2 on the denominator. That 2 will go in 24 how many times? It will go 12 times. 2 goes in 24 12 times. So this term now is simply 12h. Keep track of that. This is now 12h minus 6 goes in 24 how many times? 4 times. And what is this term now? 4 times 5 is 20. So the left side now is 12h minus 20 less than 8 goes in 24 how many times? 3 times. And 3 times 7 is 21 is that term. Plus 24h. Okay, write the next step. What will be the next step? 12h minus 4 times 5 is 20 less than 3 times 7 is 21 plus 24h. What next? Move the 24h from the right to the left and move the negative 20 from the left to the right. That will be 12h minus 24h, alright, moved from the right to the left. 12h minus 24h less than 21 plus 20. And now 12h minus 24h is negative 12h is less than 41. Divide both sides by negative 12. When you divide an inequality by a negative number, reverse the sign of the inequality. Alright, let's do that here. Negative 12h is less than 41. Divide both sides by negative 12 and reverse the inequality. Negative 12h over negative 12 is greater than, less than became greater than 41 divided by negative 12. Negative 12 and negative 12 will go. We have h is greater than 41 divided by negative 12 is negative 41 over 12. Well, negative 41 over 12, can you convert that to a mixed number? It will be negative 3 and 5 over 12. There you are. H is greater than negative 3 and 5 over 12. On the number line, where do you find negative 3 and 5 over 12? Over here. That is negative 3 and 5 over 12, or negative 41 over 12. And greater than, arrow to the right. Now, is negative 41 over 12 included? No, we have a parenthesis. So on the interval notation, it will be parenthesis, negative 41 over 12, comma, infinity. All right. I think we did a number of problems in inequality. And I want you to be very, very thorough with solving inequalities. It's a very important skill, and you must do now all the homeworks that I have provided. Okay? And now, this brings us to the end of Unit 2. That means you are now ready for your Unit 2 test. I hope you did the 2 quizzes well. I'm actually monitoring everybody's scores and the way everybody did these quizzes. Alright, if you have any problems, you got to come back to me and ask questions. Alright, first of all, after doing all the homework, do the practice test. And only after you are satisfied that you can do all the practice test questions, you attempt the test. To make sure that you understand these concepts well, because you need to prepare for the final exam and the state exit. You see, you can pass all the tests I give you, but if you cannot pass the final and the state exit, you will not pass this course. So spend time and learn these concepts, alright? I wish you best for the test 2, and I'll see you for Unit 3 a little later. Okay?